Hey there, welcome to Tech Tip Tuesday. Today we're going to be continuing our series exploring what's inside your computer. And in today's lesson we're going to be talking about random access memory, or RAM. Before we begin talking about random access memory, I want to discuss one point of terminology that can get very confusing, and that is, what is memory? As a generic term, memory is something we use to describe storage capacity, but it can get a little confusing when you buy a computer or you're looking at what your own computer has and it's referred to in terms of how much data can be stored, and then there's a much smaller number for RAM. But they are both referencing either gigabytes, or sometimes storage will be referred to in a terabyte. But it's tough when one says 500 gigs and one says 8, but they're both memory. So what's the difference? Well, it really comes down to how that memory is used and how it's storing data. For example, this is a random access memory chip that you would commonly find in a desktop, while this one here is what you would find in a laptop. Now these have much smaller memory capacities as opposed to hard drives, which we talked about last week. But the key difference is that under power loss, the hard drive will remember what you saved there. Whereas with RAM, if it loses power, all the data goes with it, and there's no way to save it, and we call it volatile memory versus non-volatile memory on a hard drive. For the purposes of our lesson here, I think it might be helpful to think of hard drive memory kind of like a book, where it's written down, it's more permanent, it takes longer to get to, but at least you're not going to forget it because it's written down or printed. Whereas memory is kind of like the memory inside your brain. Now this analogy isn't perfect because we do have the ability to remember things for long periods of time, but as a general rule, we are going to be able to store much more information in book format than we could ever really hope to memorize. So let's talk about what random access memory actually does for us. Picture you're working on a research project. To your left, you've got a filing cabinet full of research papers, and you've got a nice big desk in front of you. You take a few papers out of the filing cabinet and you lay them out. You begin to study by reading these notes or seeing things that you've worked on in the past, and you're building a case or putting something like that together. The filing cabinet represents our hard drive that we talked about last week. It's long-term storage, it's reliable, it's safe, but it's kind of slow. It takes more time to go to the filing cabinet and to pull the file I want, as opposed to just looking down at the table in front of me and grabbing the paper. This table is what represents our random access memory. If we run out of table space, we're going to have to either start stacking our papers or putting some back in the filing cabinet when we want to draw a new one. Now, we could solve our dilemma by doing a couple of things. We could decide to have fewer papers out at a time if the table becomes full, or we could get a second table. This would be like getting a memory upgrade. If we add additional random access memory to the computer, we can have more papers out in front of us at once. Now, this is where the analogy does break down a little bit, because unlike a human, where we can only study 1 or 2 pages at best at a given time, a computer can keep open as much as it's got capacity for. And if we extend that capacity, it can open more programs or have more files open at once, or continue to process information until that amount of capacity continues to fill. Now here's something you can do to see this in practice on your computer. If you're using Windows 10, right-click down on the Start menu and click on Task Manager. When the window loads, click the Performance tab. You're going to see a memory graph. Go ahead and click on it to make it bigger, and let's observe where it is without doing anything. Now this graph is showing us how much memory is in use based on the programs we currently have open. Now some of it's being used by the operating system, so even if we closed everything, it would not go down to 0. Now let's start opening some programs. I'm going to open Google Chrome. I'm going to go to a website. And now I'm just going to even launch another tab. And now for fun, let's open Microsoft Edge. As you can see, as we open programs, the memory in use goes up. So picture our table analogy. Let's say you're using your computer and you notice it's frequently slowing down. One thing you can do is simply prevent extra programs from running. It's not really making your computer any faster, you're just using the resources you have more diligently by not consuming all your available memory. Now, obviously, this is only going to go so far, and it will only work if there are things you can afford to close and still do the work you need to do. If you are finding that your computer's consistently bogging down and you check this graph and it's constantly hovering above 70, 80, or even 90%, there's a good chance that your memory bottlenecked. What I mean by bottleneck is this is the first part of your system that's going to slow down. You have other resources that could continue to work, but they can't do anything because there's no room left on the table. At this point, you can upgrade your memory or close out applications. But many of us need these applications, and applications are starting to consume more and more memory as hardware and software technology changes. So it's very common to do a memory upgrade. It's a relatively simple task that can expand that table space and allow your computer to work on more things at a time. So if you notice this graph continually trending above 70, 80, or especially over 90%, you're going to want to consider a memory upgrade. Before we wrap up, I do want to mention one of the key giveaways to a failing memory module, and that is none other than our blue screen of death, as it's been called for years. Memory is extremely sensitive, and programs do not like to be changed unexpected while they're loaded into memory. This would be like you laying those pieces of paper out on the table, and then me running up while you're not looking and covering a bunch of stuff up with whiteout. When you glance back, things are going to be missing. It's not going to be the way you expected it to be. And computers typically react by crashing. And if the wrong thing crashes in a Windows environment, you're going to get a blue screen. Now, many things can cause a blue screen, including bad software. But it's pretty obvious that if you begin to get many of these blue screens over a short period of time, especially with different pieces of software, you've probably got a failing piece of memory. I certainly hope this video has been helpful. If it hasn't been because you are getting repeated blue screens and you are just frustrated that your computer keeps crashing, go ahead and set up an appointment and we'll get that memory checked out. If your computer's performing well, now you know how to observe how much memory is actually in use, and you can find out, is this the thing that's slowing down my computer and doesn't need to be upgraded, or do I just need to close a few of those browser tabs? Either way, I hope this has been helpful. Go enjoy your technology.